In this video, we'll show you how to draw the Lewis structure of sulfuric acid, H2SO4, and help you understand each step along the way. To begin drawing a Lewis structure, the first step is to calculate the total number of valence electrons in the molecule. This can be done using the periodic table, which is based on the electron configurations of the elements. Let's start with hydrogen. Hydrogen is in group 1 of the periodic table, meaning it has just one valence electron. Since there are 2 hydrogen atoms in H2SO4, we multiply 2 times 1, giving us a total of 2 valence electrons contributed by hydrogen. Next, we look at sulfur. Sulfur is in group 16, often referred to as group 6A, which means it has 6 valence electrons. These 6 electrons come from its outermost energy level, as determined by its electron configuration. Since there's only one sulfur atom in this molecule, it contributes a total of 6 valence electrons. Now, let's move to oxygen. Oxygen is also in group 16, so like sulfur, it has 6 valence electrons. However, in H2SO4, we have 4 oxygen atoms. To calculate their total contribution, we multiply 4 times 6, which equals 24 valence electrons from oxygen. Finally, we add these contributions together. 2 electrons from hydrogen, 6 electrons from sulfur, and 24 electrons from oxygen. This gives us a grand total of 32 valence electrons to distribute in the Lewis structure of sulfuric acid. Now that we've counted the valence electrons, let's move on to an important step: understanding how many bonds each atom can form in the molecule. Hydrogen has just 1 valence electron, so it can form only 1 single bond. Oxygen, with 6 valence electrons, can typically form 2 bonds to satisfy the octet rule, completing its outer shell. Now, let's talk about sulfur. Like oxygen, sulfur has 6 valence electrons and can form 2 bonds to fulfill the octet rule. But here's the difference. Sulfur is in period 3 of the periodic table, meaning it has access to d orbitals. This ability to use d orbitals allows sulfur to expand its octet, meaning it can form more than 2 bonds, unlike oxygen. Next, we need to choose the central atom. In H2SO4, sulfur takes the central position because it has the ability to expand its octet, unlike hydrogen or oxygen. Now, we arrange the 4 oxygen atoms around sulfur and attach the 2 hydrogen atoms to 2 of these oxygens. In most molecules that contain both hydrogen and oxygen, the hydrogen is bonded to oxygen, and the oxygen is bonded to another atom, in this case, sulfur. Now, let's move on to connecting the atoms. We start by using single bonds to connect the 2 hydrogen atoms to oxygen atoms, and then those oxygens to the sulfur atom. This leaves us with 2 oxygen atoms still to be connected. Since each oxygen needs to form 2 bonds, we'll use double bonds to connect these remaining oxygens to sulfur. And there you have it, the complete Lewis structure of H2SO4. We've placed all 32 valence electrons, forming 8 bonds and leaving 8 lone pairs. While the oxygen atoms follow the octet rule, meaning each is surrounded by exactly 8 electrons in its outer shell, with each bond contributing 2 electrons and each lone pair adding 2 more, sulfur is surrounded by 12 electrons, which is perfectly fine because sulfur can expand its octet. With this structure, we can clearly see how the atoms are connected and how the electrons are shared to form a stable molecule. I hope this explanation has helped you understand how to draw the Lewis structure. If you have any questions or need further clarification, feel free to leave them in the comments below.